How's it going, everyone? Welcome. Leonel Gonzalez here. And today, let's take a look now at the chapter 2, where we talk about serving the JavaScript to explore and then to get a practical sense. So, combine the theory and the practice when it comes to understand what we are doing in JavaScript when you need to offer your service to somebody else, right? So whether it's you're offering your services as a consultant or as a freelancer, or ultimately if you're building a product, a web product. Now, because of that, I'm not going to dive deep into the uh, previous chapters. I do think that actually I quite well aware of how do we get here. Just to make a quick recap of how do we get here, despite no point in tense or repetition. But yet, in today's video, we're gonna focus our attention is on chapter 2. So in the chapter 1, we look at what is JavaScript, who made JavaScript, what is the code name, and what is known as Mocha, and why the name of JavaScript itself, which is an artifact of the marketing shenanigans, where the idea is to target is Java developers, right? And who now owns the legal trademark of that, which is Oracle, and who oversees the technical spec, which is the TC39 commit, and what they're doing, how they're doing, how you can collaborate with these proposals, and how this proposal actually made all the way up to the final spec. It have to pass through all of this stage from 0 to 4. The TC39 is made of several people that are from different industry, web related industry, whether it's browser makers, device makers, and bi-monthly usually they get in the room and now debate and pass all of these champions or proposals through different stage. So this process can take like 2 to several weeks, months, or even years, all right, to actually now be able for those JavaScript implementation or those JavaScript engines to implement those spec into their engines, right? So because these JavaScript engines and also that the TC39 actually doesn't know the reality of the web is quite hard, not because they're not competent, just because it is so vast, whereas the JavaScript engines actually know the reality of, they're more closer to the reality of the web. And because of this mismatch, sometimes we have things like smooshgate, right? When the TC39 have to go back quickly to the drawing table and then refine the proposal or the champions to actually make all the way up and then update the spec. So we got the smooshgate, and also some of those JavaScript engines do legacy reasons. They choose to not even follow the spec, and most of the time they actually follow the spec. So because you have now different places where you can run JavaScript, okay? So we have is these different environments like the browser or the server or the light bulbs or robots, and because each one of them expose certain API, it is important for us to understand this different, which is when their gap, something that Kyle's in summation, I am agree with him when you say when your knowledge or your understanding of how JavaScript works and your thinking diverse, that's when a bug is introduced. So I mentioned this because JavaScript, it in itself, the people that oversee that They don't want to break the web, okay? And the only reality that matters, despite all of this environment, is the web. So with that, then we look at the that JavaScript. After all, not all JavaScript environments are JavaScript. So a good example of this is the dev tool. So for example, when you use a string, this only behaves per season, where the reality is that that behaves as a file, all right, or per functions. Another is that when you define is a functions or a variable in the console, is going to be attached to the global object known as window, which is something that not happen when you have is a file, a JavaScript files, among other stuff that happen. But the TLDR is that those environments or the console or this JavaScript, particularly the dev tool, this is not meant to be a strict JavaScript implementation of the language. It's just a friendly environment, okay? And it's important to recognize that. Now, then we'll look at the different approach for development that we can go with: procedural, functional, and object-oriented programming. How to since the TC39 wants to guarantee that the JavaScript doesn't break the web, so they provides this backward compatibility. So that's one of the reasons why we have these polyfills or the shims, right? So we can now use is the new or the latest JavaScript syntax, and now delegate that this polyfill to a particular library or community. When it comes to transpile that text, or in other words, you have your latest syntax, and when you use transpiler like Babel, to target is a code that can be understood by a huge variety of environments, whether it's JavaScript engines out there. So for the mobile, for the desktop, for tablets. By understanding this, we ask a question. First, what is a transpiling? And more important is like how JavaScript actually works. All right, is this JavaScript a compile language or is it an interpreted language? The TLDR is that JavaScript is, in essence, is not in practice a compile language. Why? Because when your file leave your ID, it's going to be transpiled to a particular ES target, again, that can be understood by a huge range of environments out there or JavaScript engines out there. And since these JavaScript engines, they can implement they will implement the feature, they stick to the law, but at their own pace. So because of that, this transpilation is used to actually address that particular issues, as well as the polyfills. So once your file leaves the ID, it's going to be transpiled to one of these specific version of JavaScript, and then bundle up, whether it's by passing it for a series of build steps or Webpack or Vid, yada 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 yada. But the thing here is that code is ready to be delivered. So once your JavaScript engines receive that, it's going to parse that into an abstract syntax tree. So in other words, it's going to parse for early errors. You can actually check that on the spec by looking at the syntax semantics and the runtime semantics. This is the indicator that the language in itself is now running some previous step before execution, right? So a good example is that this syntax error or these early errors when it comes to detect that, all right, whether it's evaluating is functions or syntax, whether it's as the name suggests, syntax errors, okay. So this process happens, and then is generating is an abstract syntax tree that is gonna generate is an intermediate representation of binary code, usually a bytecode, depending on the JavaScript engine, and then inside of the engine, that code that was generated is gonna be, uh, for example, in V8 engines, that particular code, that code that was generated is going to be passed through a compiler for further optimizations, for further optimizations, and then now the code is ready to be executed. So the concern of JavaScript is that during the parse and the execution, we want to make sure that JavaScript can be fast as it, the question is, can JavaScript be fast as any compiled language like C or Java? And the answer is that yes, because there was an attempt, there was some there were couple successful attempts to bring that. So for example, a.gsm, asm.js, when it brings that to as.js, which is a subset of JavaScript that is not mentored to authored by JavaScript developers, is just demonstrate that we can now port a JavaScript code or a C and an Unreal Engine game from reading in C to JavaScript, where this subset of JavaScript, this particular language, all right, now provides some hints to the compiler, to the engine JavaScript, to do further optimizations. And they successfully now were able is to load that code into the browser and run that game. So several years has passed. That was back in 2013. And then several years has passed to say, hey, now we have these things called a WASP, WASM, where it takes now the idea of which is a spiritual successor of ASM, but they go a little bit further by saying, hey, let's go to now skip the parsing phase by having this representation in this language like an assembly like, all right, where we can now target is language and compile into this WASP representation that can be now run in any WASP environment. So WASP, at the end of the day, is not a replacement of JavaScript. It is a universal compiler target. So whether it is Java, Rust, C, C++, C Sharp, now it's going to compile to the WASP that can be now executing these WASP environments. I think that's quite powerful. It goes beyond the scope of today's video. And then finally, what do we really care in this chapter, right? Which is serving JavaScript. So each file is a program because this is the way of how the engines process the files, looking for errors, all right? So when you have several multiple script tags and JavaScript now process each one of them, okay? Because it's going to detect early errors, this syntax semantics that I mentioned before. If one of those files fail at best, let's say you have now Google Tags, Google Analytics, and then some Sentry for error logging, that kind of stuff. So each one of them, if one of them fail, at best you can think, at best you can hope, at best you can, uh, at best your app will operate partially. Okay, so this is what it is. Now, so each one of those files is a standalone. The only way that they now act as a single one is if they are now sharing a state, and this is the crucial point of JavaScript and for React as well, to understand is Redux and all that kind of stuff, right? So the only way that now JavaScript act all of these standalone files act as a single program is if they are sharing is their states via the global scope, all right, or they are now exposing is methods and data to other files that they can now work on that. So in EX6 we have now this co-organization known as models, whether it's import or the script tag with high models, that despite that these codes now are linking all of these files at runtime, making them interoperable at runtime, right? The thing here is that it is good to think that each one of your file is a mini program that at runtime they can collaborate and they act as a single program, right? So this is the crucial point, because as you go on to React and all that kind of stuff, you're gonna see how that state that is sharing across different UI is important. This is specific concepts of that. Now, then moving on to, well, what is a value in JavaScript? How can we determine value? Which is the unit of is the most important unit of information that allow us is to project. Okay. That allow us is to project here, or to represent is the state of our programs and maintain the state of the programs. That's why we use values. And if it wants to maintain the state of the program, whether it is as a string or as a number, each one of them has a spec that it follow. So for example, in the string, it follows the Unicode, this binary representation, this binary sequence of all of this, that allow you to represent is not only is Latin alphabet, but also is Arabic or hand-based, which is like Chinese or Korean, Japanese, Vietnamese, Philippines, right? And then also the astral plane, which is the the emojis and all that kind of stuff, and the composition of those emojis. So, but the point is that this is on the string. This is also on the numbers that follow is the IEEE 754. That it's a sequence of binaries or of bits that allow us to represent something. And the pattern here is that in software, when you define is a sequence that allows you to represent this is where the powerful things comes up. So the Institute of Electrical and Electronic Engineering actually make a tremendous amount of work, but it's huge, man. We actually is on the short. I am here, and we are here. Thanks to the short is. Oh my God, it's because it's overwhelming here. The sensation, but in any case, so we are here is because you know So we are here because we're standing on the shoulder of giants. Now, we also can use booleans to represent states in our programs and to maintain the state in our programs. Big int, as well as the kind of emptiness, such as null and undefined. Why we prefer to go undefined rather than null, as well as symbols, which is allows to represent these hidden values that they are obfuscated, they cannot access, we cannot read as JavaScript developers. Okay, and this is useful for low-level libraries as well as frameworks. And also big ints when it comes to represent huge numbers, okay, that the spec is IEEE 7054, which is the way of how you can represent numbers, actually fell short to describe these long numbers, all right, and as well as it is precision when doing some mathematical operations actually is quite annoying, right? A good example of that is when you go here, is when you do this, okay, so a good example is because you have now this built-in limit in the number object. It say is safe integer, right? No, but I want is say max value. This is the maximal value that you can represent, which is an integer, right? The other is the mean value, all right, which is now a fraction. This is the minimal value you can represent. Is a negative fractions here, and also it's a negative number. Sorry, it's a negative integer whole number, and also is the max safe integer, which is this. So when you're starting to doing operations on this number, so for example like +1, and then when you do that +2, you see that you get this funny last number that it doesn't actually represent that. This is because of there is a problem of accuracy. Again, this is going to be on the scope of today's video, but it's important at least to understand that. So big int allows is to, well, if you want to now by adding is an m, do this with m, you can do this, similar for this, all right, and it actually is allow you to represent this number as it is, and the only thing that changed is this, because this is a way of how now JavaScript interpreted that this is not a number, this is not following is a sequence, this actually follows this another representation, the big int. So in any case, and also we have is now objects. So with object, it allows to represent is collections of values, like an array it's a numerically indexed collection of values, all of the values that I mentioned, as well as the arrays, objects, which objects are now a key value. It's a key value map, okay, that allow us is to define it as a key, as a string, and then now a value. Functions is another kind of value, and also you can use functions to put in the array. So why this is important in terms of functions? Because I don't want to make a quick pause here to describe is like the roles that actually arrays and objects play here. So you have on the array the role of a dictionary, sorry, the role of a list or a tuple, and the list is that with all of those collections, you don't know the length of that. The length might vary, but each one of those elements, the value is the same. Whereas the tuple, where this is a fixed length array, where each one of those values can be different stuff. And then on objects, you have now is a dictionary or a record, where a dictionary is an arbitrary number of arguments, of an arbitrary number of key that you don't know at development time, where each one of those values must be the same. I think it is. And where you have a record where it is a fixed length of keys. It is a fixed length of key where each one of those values can be different. So this is a good segue here that I want to clarify a little bit. All right. The role of JavaScript, exactly. The role of JavaScript, exactly. The role of object in JavaScript. The role of objects in JavaScript are dictionaries and records, where the first is an arbitrary length of keys that can have that have the same values. Okay, it's an arbitrary length of keys that have the same values. All right. Whereas tuple, whereas record is a fixed key length. It's a fixed length of keys with different values, or where their values are or can be different. So why this is important, especially if you're gonna go with TypeScript and all that kind of stuff and yada yada yada, right? I think there might be confusion in your description of JavaScript objects. Let me clarify how objects actually works. JavaScript objects are general purpose data structure that can serve multiple roles, but the distinction you have described isn't quite accurate. Like this. So JavaScript object can have an arbitrary number of property key, and each property can have different type of values. Some property can be added, modified, and deleted at runtime, and there is no built-in distinction between dictionaries and records. For example, here. But I mentioned is on TypeScript. When you talk about TypeScript. Record is a TypeScript are actually that flexible. In TypeScript are actually the flexible dictionary like you're describing. First, let me actually update my knowledge here, tackling TypeScript here, because I want to understand the truth of this. Typing array functions. Let me also is set an alarm. Give me a second here. And we're back. All right. So now that we are here, okay, and I do think that when it comes to typing arrays, this was right array type and tuple, but my intuition fell short when it comes to describe is objects, compound types. So typing array, what about object, typing objects here. Again, this is a book from fixed layout objects and dictionaries. So dictionary is an arbitrary number of properties whose names are not known at development time, and all properties have the same type. Okay, dictionary and fixed layout. Okay, so recurring types are actually the flexible dictionary-like structures. Okay, this distinction of the role is quite crucial. The dictionary-like structure you're describing first, the records here, the key and the value, utility type creates an object type with arbitrary keys of type key. So this is so. I know this is part of the TypeScript, but it's important at least to understand that how you can actually use these arrays and objects. Okay. So that's what you have is the record, okay, that is going to generate is an arbitrary number of elements, k, and values v, for example. An object type with fixed properties, exactly. An object type with fixed property. What are you describing as records? This defines specific, known just with potential different values. So fixed object type and specific keys and different value types. Most of the times we use this fixed layout objects to define is this, right? To define is this. However, when this is quite important since this is the way of how you can represent your data. Again, perhaps most of the time you don't need to actually in the field to describe that, but it makes a lot of sense for you to understand that, or at least for me, to understand that is, hey, yes, we have now this two role of how can we use our objects, whether it is a record, where we can use now is this to, when you don't know in advance what will be the property, what will be the key or the values of this, okay? But at least you know the type of this. You don't know you don't know in advance, which is the record, exactly. In record or dictionary. So with records or dictionary, you don't know in advance is the length of keys, all right? But their values, and their values can be and their values must be the same, all right? Which is describing is this. Hey, this is an arbitrary number of property whose names are not known at development time, and all property have the same type, right? Which is known as a record. Hey, I don't know the name of the property right now in development time, but I do know that the value are all the same. Whereas with this object fixed layout, which is most of the time we're used to, is that you know the keys in development time, this fixed length of elements, but in all of those values can be different, right? This is the difference between is a type and a record or an interface. Now, most of the time is the type or an interface versus the record. Okay, what will be the three main use cases for for a object in a fixed layout, because it's a layout fixed layout object and a record. Exactly, fixed layer objects. So for example, data modeling. Data modeling is something that you know in advance. So you use type or interface, right? And the other is functions parameter return type. So for restructured data type with a specific required fields. So when it okay. Hey, this is now the data that I'm expecting to receive or the data that I'm expected to return in terms of functions. And why we are going to have this discussion with functions, which is part of the today topic. Okay, so functions, and with functions, right? Uh, yeah, let's gonna keep looking at this configuration objects. So when you lead to setting with known keys, you use is this, right? And the other is the record. Again, you don't know the keys of this, but you know that all the values are the same. And they say, hey, look up mappings. So when you need a dictionary structure for fast key based access. Oh, exactly. The other is dynamic grouping. When you're grouping, here is this grouping data. So when grouping data by unknown keys at compile times. Okay. That is interesting. Users by that, and you're gonna get all of this. So you don't know in advance the collections of all of this, but you do know is the value that you're gonna get. Interesting. Dynamic grouping. And the other is catching and memorization. Why is catching and memorization? Because hey, you don't know in advance what are the keys you want to store. Let's say is all of this user interface, a small snippet of user interface. But you do know is the value of this. Get catch data. So get me whatever you have in the catch, or call the fetch in key here. Again, this is the most common use of this. It makes a lot of sense. And when we talk about is function, which is why we're gonna focus our attention in today's video, as well as other topics, there is this. Is because we were talking about the values, right? The values is the primitive and the objects, and how in the objects we can have is arrays that allows to represent is collections of values, whether it's in a tuple or in a list. And in objects we can now is a this key value like a table with the key and the value, right? A table with two columns, right? And since the values, whether it's on the objects or on the arrays, can be all of the primitive, as well as an array itself, or an object, or a function. And this property of the function is crucial if a language wants to use functional programming, which is this particular approach to solve specific problems. And when it comes to computations and calculations, so hey, by following these particular techniques, it makes our life much more simple when it comes to maintaining the bugs applications, right? So we can get rid of a huge entire classes of bugs by stick to these functional principles, right? And this is why, for example, functions in JavaScript is a broad term, because you can use it as a procedure, which is a set of statements. It's a collection of statements, and the statements in JavaScript is anything that calls to an action. You can also look at this statement. What is a specific statement? All right. So for example here, what is a statement declaration? So you have, hey, a statement is a block, it's a variable, it's an empty statement as well, and it's an expression statement. You may wonder what is an expression at the end of the day. Anything that produces a value here. So expression statement is this, okay? Anything that is, except that is each one of those, which is that's what it's gonna tell you here. So look ahead that anything of this doesn't belong to this. All right. Now that'll be expression. So an expression can be an assignment. Okay, that is an expression, and this assignment expression can be conditional, it can be yield, it can be arrow function, async arrow function, left hand side expression, and left side expression as well, right? So this assignment expression, as I mentioned, all of this, right? So this is an expression. This is it is also an expression here. So when you do an left assignment expression, so whether it's a condition is an expression, yield is another expression, arrow function is an expression, async, arrow, left hand side, and all of this, as well as an expression, which is this, is kind of recursive, or assignment expression here. And this is now to understand what an expression means into the language. And I do think that a lot of content out there that focuses on kindergarten introduction or junior roles and so on and so forth, I do think that is quite interesting, quite powerful, quite helpful. But if you want to actually is now deliver value and solve problems and create now things that go beyond the basic stuff, whether if you're working for as a consultant or if you're building your own products, so you do need to know is how all of these things actually works, and how it is not mandatory, but is it at least to understand what you are doing here. So yeah, this is the assignment, okay? A condition is a statement, it's an expression. A condition is an assignment expression, interesting. A condition, a yield, an arrow function, an async arrow function, a left-hand side expression, okay? And a left-hand expression with assignment operator, which cannot be all of this, right? So this is now an assignment expression. And so now that we know what this expression is, if a statement, breakable statement, and breakable statement is an iteration, all right? This is also an expression or a statement here. As you can see, it's a call to action. Do is a reserved keyword, while, for, and all of the things that you can do with a for. Also, you can is a wait for a for. You know what I mean? You know what I mean? This is quite interesting. Wait for a for. I wasn't aware of this, but I do know that this is possible. Okay. So this is for synchronous looping, and then you look now for asynchronous looping, right? For example, is now I do want to know a particular example of this. So make a simple example here. So given the following text from the spec, provide examples. Provide 5 different or provide 5 real use cases. Provide 5 main real use cases. And before that, I want to provide now a particular statement here, which is this one. So what I'm gonna do here is this. So before answering, okay, work through this step by step. So understand what is the core question being asked, analyze what is the key factors component involved, reason what logical connection can I make, synthesize how do these elements combine, and then conclude what is the most accurate helpful response. And now my response, and now you do is this. So now answer this. Step-by-step analysis. Understand. So what is the main question here? What is the core question? What is the heart of this? So the question asks for real use case for the await of loop syntax from Emacs create specification. You right? Analyze the spec show 3 variants for await left hand side, for await var bindings, and for await let cons declaration of async. It's an async iterable. Interesting. It's an async iterable of assignment expression, yield and await, and a statement. So we know what a statement is. We were actually looking at this statement. Breakable, continue, break statement, return with statement, with you shouldn't use with, label statement, throw statement, try statement, debugger statement. Okay, whether it's this statement here, you can also have is statement here. Okay, but during here, this is an assignment expression. Okay, an assignment expression, it can be a condition, it can be an arrow function, it can be an async arrow function. Interesting. Okay, it can be yield, and it can be a left expression here. And let's take a look now at this. The reason: consume async iterable sequentially, handling problems that resolve over time, processing and streaming data, managing back pressure in async operation. Synthesize. The synthesis enable of this. So for example, it is processing API pagination. So here you can actually process is this. That's quite interesting. Okay. So whether it's returning is an iterable, all right, reading file streams as well. Okay, to process this, oh, that makes a lot of sense, nigga. Oh man. That makes a lot of sense. Okay, to process these streams of data here as an async iterable here. Hey, you're gonna receive all of this encoding character as chunks to handle back pressure when you're reading a file or when you're receiving streams of data as well. And this is, look at this, this is an async function fetch all pages. So you are going to call that, all right, on the API user here. Holy moly. This is gonna trigger is this, okay, for each one of them. It's going to evaluate is this, because here this after the off is an expression. As you can see here, it's an assignment expression. An assignment expression on the left side if the of is here, an assignment expression, it can be an assignment expression or an assignment expression. And it can be conditional, a yield expression, an arrow function. In our case, this is not an arrow function. This is a async arrow function. Holy moly. So let's explore about this, shall we? Let's explore about this, and then we're going to now continue to read this. So if for some reason you say, hey, async function fetch all, and I'm going to hit is a particular URL that I'm going to provide, for example, is URL typing hit or API hit target or API hit API. I think it's typify. No, anyway, API mock data, right, for testing. JSON placeholder, which is this is exactly what I was looking for. Is this one? So I want to fetch is only one. Okay. I want to fetch a post or a user. But what is the URL of this? Oh, is this one? There, you got it. Okay. I'm gonna put it here. Of users, I do think it is users exactly. And come on, chill. And what I want to do here is to this is now an async function generator, exactly, which is any time that I provide a URL, is going to run this. Okay, and this is now provides pagination. Okay, all right. Again, I'm not sure if they actually is providing some pagination. Let me do thing how this is returned. No. In fact, if I do this, the users, okay, doesn't provide any pagination. All right, this API doesn't provide any pagination, which is good. But I do want to fetch is all of his data here. Yeah, this API doesn't provide pagination, so we don't need to call this in a sequence of data. Okay. Read file stream, processing real-time data feeds. Batch processing with rate limits. Yeah, batch processing with rate limiting. Here. And then you're gonna get is now this URL for that. And the database cursor interaction. MongoDB style cursor, DB user collection, batch size. But again, all of this is to process now huge chunks of data and to deal with the back pressure. Which is how do you how do you handle a host? It's like how do you handle a host when you how do you handle a host when you grip it here? How do you handle as a host that is flowing water at certain pressure, and then suddenly your brother or your pal or girl is actually uh, open up that uh, faucet, you know, and then you have much more pressure here. So this is exactly what is handling with the async iterator or this iterator. If the sequence of data as they come in in a way to handle this particularly issues here. Mm-hmm. That makes a lot of sense. So, all right, that was quite helpful to understand, you know, to make sense of all of this. And yes, all right. So yeah, we will. All of this was to understand is now the functions as a value and look at the spec when it comes to describe is what actually precisely these things means, okay, and then you and avoid trying to numb you down particularly concept, especially this is something that is quite useful and helpful here. Why is this? Well, because at the end of the day, here is actually when you're learning something that is mechanical, it is by all means follow these instructions, follow these recipes. Okay, it's not that hard. It actually makes a lot of sense. Okay, you're going to develop these intuitions about this, and it all start is to understand what a statement is. Okay, here you can actually take a look at that and dive deep into this, and then as we what we're doing here, right? And then because functions at the end of the day isn't a statement, it is a value, right? Which is useful to and use now as a which is useful to enable now JavaScript as a functional programming, which is not all language provide these features, but language like Python and Go actually they provide this functional programming. We can actually benefit from the uh, techniques that is being used in the language, that is being used in the functional programming. All right. So for example, is high order functions. How do you pass now functions as values or return functions as value? This set of instructions to be executed later on. Or you can use now functions as a value in your table, in your hash, in your object. And anytime you want to run that specific transformation, you can just call that, right? Hey, I want you to run this transformation of this particular data set or this in another data set or so on and so forth. I do think this is quite mind-bending and quite useful. Absolutely. All right. And I already asked that to. Let me see if I did this here. No, this is more about the functions declaration. Again, something we're gonna explore in today's video. Cervical spine decompression techniques. No. High cholesterol lab result. JavaScript functions hoisting mechanism. JavaScript object type and structure. No, it's none of this. So in any case, I can now ask him about that. Let me actually delete this couple one and ask a new question and say, hey, you know what? What? Let me copy here this to actually enable is or to touch more of this sensitive neurons in the large language model. So we got is this. Systematic problem solving. Okay. And I can do something like this. Now your answer here, it is why functions are values in JavaScript. Okay. What is the core question being asked? The question is asking why JavaScript treat functions as value, meaning they can be assigned or passed as return that. Technical implementations in JavaScript engine functions are actually objects. Exactly. Practical benefits and language design, historical context. Brendan H designed JavaScript with inspiration from language like scheme, functional, and self prototype based, both of which treat functions as first-class value. And this wasn't an accident. It was a deliberate choice to create a more expressive and flexible language. The language design. So what are the patterns we can use in functional programming in JavaScript? So core transformation patterns, functions composition, right? Hey, you have these collections of functions that you want. Okay, this function composition is huge because you have now these collections of functions here that you want to apply each one of them, right? Given this particular value. So this composition or function composition pattern is pretty much like passing through an assembly line, all right? You pass a value to this function through this series of functions, through this series of transformations, and then the output of the first will be the input of the second function, and the second function output will be the input of the third function, and so on and so forth. I am quite familiar with this. Perhaps I do need to practice a little bit more, all right, to understand what pipe encompasses, whereas pipe start from the right. I do think it starts from the left, or for the first function, and then pass through that. Whereas compose start from the other side of the function, from the last function, and start to that. Then you have now currying and partial application. And I do think, and I know why they actually asking this kind of stuff, right? It's like, hey, how do you actually transform your functions into that? So you got all of this length, and if the length is greater than the function length, okay, which means to actually to compare that, as long as the as long as the argument and the function length, which is the arguments, are greater, okay, it means that it means that you are going to now call is the functions, or you are going to query that, you're going to call that in a recursive way, and then pass this values as it is. So you're going to pass a function and bind all of the arguments that you have received so far and call that again. So this might be quite mind-bending. I do really need to work on this, because now this is part of the fundamentals of the language. Hey, you need to understand how to work with object-oriented programming as well as the functional programming and the techniques that is using here. Higher order function, I am well aware of this. All right, decorators and middleware, okay. It's like, hey, in these functions, I want to now is perform this set of actions or do this kind of stuff here, and then return these now a new functions to that. With memorization, immutability patterns, right? And this immutability pattern is to say, hey, I do want to is not mutate the state of the app. In fact, it's return a new state out of this, which is something that we have here, right? The other is the monadic pattern. I am not well aware of this monadic, safe chaining, and all that kind of stuff. But I do think is that if you want to change that, maybe optional pattern, and either pattern for error handling. Advanced composition patterns. Exactly, map, filter, and transducer. I am well aware of the filter or a map, but not of the transducer. Function pipeline with async. Function pipeline with async. Interesting. Function pipeline with async, which in other words, it say, hey, you're gonna receive this function as values the first time, and then anytime they are called, when you call these functions again, you're gonna pass is the value, and when you pass is the value, okay, when you call this function and pass the value there, okay, then you're going to go through each one of those, okay, and run this. So evaluator is an expression here, so evaluate this expression here, and evaluating this expression here, which is an async functions that is going to, okay, evaluating this expression here, which is going to take the accumulator and the current value, all right, and evaluating this expression here, and call the function with the await and accumulator, which is the function in itself, all right, and this will be the initial value here. These patterns work together to create cleaner, more predictable code. The key is starting with pure function and immutable data, and then building up complexity through compositions rather than mutations. But again, all of these things that I am more quite well aware of the core transformation patterns, map, filter, and reduce. The composition pattern is quite actually interesting and useful. The other is the currying and partial applications. Is that how do you actually is transform with a function parameters into something that is unary or binary? Okay, how do you now change the shape of the parameters here? Exactly. And then evaluating is this. Or currying or partial application. And the other is the high order functions. The immutable updates, which is something that React has now show you that this is the way to do things, right? Deep update with lens, arrays updates. So for example, like this is like, hey, return is a new collection, so make a new copy of this, right? Make a new copy of this and ignore the previous one. So make the other and then the transducer and all that kind of stuff. Okay, so it makes a lot of sense here. It makes a lot of sense. So, but the thing of all of this, because we go a little bit further, let's go back here to what we care, and that is, hey, we do want to know is the function, the function's anatomy, all right, which is something that we're gonna see a little bit further in depth in other sections, and how you can now, since functions is a value, how you can determine is a function, how you can determine is a value in a program using the type of. Why is this important? Because here you can actually see what a value it is. Okay, so you have now number, string, boolean, big int, undefined, null is an object, array is an object, function is a function because this is a value, and objects are now objects. Okay, so by looking at and see how we can declare variables in there. Okay, yeah, absolutely. So by looking at and declaring and using variables there, we now were able to decide. Okay, we were able to look at what a value is, what are the type of values, whether it is a type of value of literal, or it can be held in a variable, and this variable act as a containers, and this variable has different syntax forms with inherent behaviors. So for example, we have the var let and key, okay, var let and cons, where each one of them is allowed to decide is how widespread we can make this function, this value, all right, across our applications, all right. So whether it's globally or per functions with var, or in the case of let is on a block scope, all right. And this cannot be redeclared. In cons, which is an even further constraint, set further constraints about set further constraints with let that you, which is a block scope, you can is redeclare or reassign this value later on. However, it doesn't talk about any mutation. So with primitive, it will work. The deal is that work with cons, okay, work with cons for primitive, right? So you can now eliminate is the 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 confusion about cons with objects, all right, where you can redeclare a variable with cons or reassign, but you can mutate the value. And this is the nuance of the language in itself. Now, uh, we also look at where can we, in functions, you can define variables, okay, such as with parameters, okay. Also, when you use a functions, declarations is another way of how you can define a variable or an identifier, okay. So like when you use a variable definition, you can do that. And here, because as I mentioned earlier, functions is a more broad term that in JavaScript it can be a procedure or it can be a function in the mathematical sense, in the strict sense, okay. And how you can define function is whether it's functions declarations or function expressions. And functions declarations, the binding between the identifier, the name of the function, and the value is happened at parse time before the code is executed. And the other, and I do want to know, uh, so in 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 which part of the spec the following sentence can be found or similar. The function definition, okay, yeah, the function definitions, yeah, the function definitions yeah, the function definition, the function's declaration, or the association between the identifier in the function declaration and the value happens at runtime, at parse time. Exactly. The spec doesn't use the informal term parse. However, the counts that you're referring is to describe informal terms. Is here. Section 15.26 function declaration. The spec describes function declaration as being instantiated when the execution context is created before any code runs. Functions declaration. Set mutable bindings. 9.1.15 get binding value. This describes how functions declaration binding works different from var declarations. And functions declarations instantiation. This is the key section. It specifies that functions declarations are processed during the instantiation phase of the execution creation. Functions declaration instantiation. Instead of parse time, the spec use terms like instantiation time, when the execution context is set up. Declaration binding instantiation, the process of creating bindings for declarations. Declaration binding instantiation and hosted. Though this term appears mainly in notes, not normative text. The actual specification text. The closest formal description is this: function declarations is instantiation, which state that the function declaration is processed in step 27. Let's get into this. Functions declarations. Functions declaration. Functions declaration. Functions declaration instantiation. At least at this version. Ignite. Oh, there's some change here. Change to function declaration instantiation. But is this? And it performed 27, 28. For each parse node in functions to initialize built-in functions objects. Okay. Functions declarations instantiation. When an execution context is established for evaluating the ECMAScript functions, a new functions environment record. So it created an execution context. Okay, it created an execution context. Okay, is established for evaluating the ECMAScript functions. Okay, an execution context is created, is established for evaluating the function in itself, and a new function environment record is created. And bindings for each formal parameter are instantiated in that environment record. Okay, and bindings for each formal parameter are instantiated in the environment record. So in other words, a functions declaration instantiation, it when the execution context is established, okay, an execution context is a specification device that is used to track the runtime evaluation of code by ECMAScript implementation. At any point in time, there is at most one execution context per agent. This is actually executing code. This is known as the agent running execution context or the global scope. All reference to the running execution context in different specifications denote the running execution context and the surrounding agent. The execution context stack, and this is the stack, but here you're describing is this. Is an execution context, a specification device that is used to track the runtime evaluation code. So this execution context is a device that is used to track a runtime evaluation. Okay, so it is created to keep track of the runtime evaluation of the code. Interesting. At any point in time, and there is at most one execution context per agent. And the execution context stack is used to track execution context, and the running execution context is always the top elements of the stack. This is what we call about the call stack. But what it's doing is that any time that an execution context is created, the context stack is used to track this execution context. And the execution context is this device, all right, that is used to track the runtime evaluation, which is, hey, we're in this line, yes, in this line, to keep track of that. Okay, not only that, okay, but also it is a function environment record. A function environment record, which contains the value of this, which contains the value of this binding status, lexical initialize, uninitialize, Again, this is a private method. Function object, the function object whose invocation caused this environment record. The home object, if the association function has super property access and is not an arrow function, then you get it. And the new target here. But again, all of these are private methods for the function environment records. You can't have access to that. All right, this is internal use. And the function environment record is a declarative environment record that is used to represent the top level scope of a function. And if the function is not an arrow function, provide a this binding. If the function is not an arrow function, functions are referenced super. It is function environment record also contain the state that is used to perform super method invocation from within the function. It is describing what is this, all right, as well as these abstract operations. Has this binding, has super binding, get this binding, get super base, and the global environment records. Okay. But when we creating a functions here, this is actually quite interesting. So when an execution context is established for evaluating, when an execution context is established for evaluating an ECMAScript function, for evaluating an ECMAScript functions, a new function environment record is created, and bindings for each formal parameter are instantiated in that environment record. So each declaration in the function body is also instantiated. If the function formal parameters does not include any default value initializers, then the body declarations are instantiated in the same environment. If the default value parameter initializer exists, a second environment record is created for the body declaration. Formal parameter functions are initialized as part of the function's declaration instantiation. But the question remains, when this is performed? Function declaration instantiation is performed as follows using function argument list. Is a function object for which execution context is being established. This is functions declaration instantiation. Functions declaration instantiation. I don't know why it doesn't open up. Ordinary and exotic objects. ECMAScript functions. I don't know why this doesn't open up. You should, in fact, open that. If I do this doesn't open up. But it doesn't open up. Why not? Why this doesn't open up? Yeah, I do want to know that. Open up. Yeah, yes. Okay. Functions here. There you got it. Exactly. Functions declaration instantiation. The abstract operation function declaration takes argument here and this. And now it declares what happened in a more readable way. In a more readable way. Provide an extension to the above algorithm that is necessary for backward compatibility with web browser implementation of ECMAScript that predates this. This is the appendix, the annex, additional ECMAScript features for web legacy. But in any case, let's go beyond the scope of this. I do want to know is when that happened. Why parse time is inaccurate? The spec distinguish between parsing, converting source text to a parse node, execution and instantiation, setting up execution context and binding. Okay. So where I can look at the different phases in JavaScript. Oh my god. Most authoritative is this: script record, model records, environment records, and function declaration instantiation, and execution context. Looks for posts about parsing, compilation, and execution. Educational resource, Kyle Simpson, and the phase breakdown, parsing, lexical analysis, the tokenization, the creation of the ASCII syntax tree, and the early error detection, and then the compilation of preparation phase, which is the scope, variables and function declaration, and optimizations preparation in modern engines. And then the execution context creation, and then the code execution. So I know that I'm going deeper into this. I know I'm going deeper into this. AST Explorer. Oh, to understand what's going on, it create now. This is the program. Parse and drop some JavaScript here and explore the syntax tree created by choosing parser. You can use all the cool new features from EX6 and even more. And this is what is the EXT is creating here. So it say, hey, I'm having is a variable declaration, and this is where you can actually see what's going on. And then I have is, for example, a for. Let's say a for cons of, so this is now the keys, the values of an iterable that I want to create here, let's say this, let supermarket list, right? You have now a new map where here you're going to define is this, right? The apples, the price, $2, right? And the bananas, 1.15, right? And then say some beef, okay, it's like $10, holy moly, right? And then now down here you can say, hey, the supermarket list, the values, we're going to produce this as an iterable where I can now console the log that, say console log this one of the key and the values, but in singular, right? In value. So this is now the supermarket. This is the supermarket list, right? I prefer to use this as string interpolation for this, and then do something like this, right? This is the key and the value. key and value. There you got it. Okay. So yeah, that's what it is. It's a unexpected token on line 20. You're right, because it's this. Unexpected token on line 2712. Counts key values. Oh, because this is in this way. There you go. And yeah. As you can see, look at this variable declaration, and then function declaration, and a for of statement here. What you get is this on the left, the right, and the block statement, where inside of that you can actually get into this. Hey, this is the expression statement that we're gonna do. So again, this is quite interesting to understand what's going on. Okay, that at the end of the day, it creates now a node or a object to represent that, right? Hey, this is expression, this is generator, this is async, and so on and so forth. Now this is the body, and the body, what contains? Oh, it's a block statement. Okay, what this block statement contains? All of this. Can I see the evaluation of this code? And if this code is Babel and printer and TSLint and Prettify, but it's this one, and all of them now generate is that's similar to Vue, you know, but all of this are just following is the same structure. What about React? Interesting, they don't put here React. They don't put here React. That is surprisingly, what the fuck. Well, any case, compilation unit, and then you have JavaScript, and okay, that's quite interesting. That's quite interesting. The AST Explorer, Babel's AST Explorer for understanding. Okay, I think that we can move on to the next topic, because I don't want to stop here. Okay, in fact, I just want to also explore that. And again, this is just the intro. To understand, to get myself familiar with this. Okay. Functions declaration instantiation. So I do think that'll be all for this video. Take care. Bye bye.